Hello, this is Patrick Holtberg, and today I want to talk to you a little bit about how to solve the basic Ricardian model. The basic Ricardian model is a model of a perfect world. So we are assuming perfectly competitive markets, no market failures, so there are no externalities, no public goods, no non-clearing markets, and so on. And there are only small countries. We'll look at two small countries. In this model, we assume that there is one factor of production, labor, and we have perfect factor mobility. This is going to be the problem that we are looking at today. So we consider a perfect world in which there are only two small countries. We'll call those Korea and Sweden. Both countries can produce two types of goods, good A and good B, but they cannot produce these goods equally well due to different levels of technology. The difference in technology is given by the following unit labor requirements. In Sweden, the unit labor requirement for good A is 15. This means that it takes 15 units of labor to produce 1 unit of good A in Sweden. The unit labor requirement for the production of good B in Sweden is 10. That means it takes 10 units of labor to produce 1 unit of B in Sweden. And for Korea, the numbers are 30 and 12. So it takes 30 units of labor to produce 1 unit of A in Korea. It takes 12 units of labor to produce 1 unit of B in Korea. We also assume there's only one factor of production, labor, and we assume that each country has 9,000 units of labor. This is the resource of the country. Labor is perfectly mobile between the industries, but perfectly immobile between countries. This means that labor can go from industry A to industry B and back anytime it wants, but it can never go from one country to another country. Finally, we will assume that preferences are such that each country has elected to allocate half their labor force to each industry in autarky, that is, before trade is allowed. Okay, given this setup, the first question is, which country has an absolute advantage in the production of good A? We define absolute advantage as a country that can produce a good I using up fewer resources than another country. So the way we would look at it in terms of good A, for example, is that in Sweden it takes 15 workers to produce 1 unit of A, whereas in Korea it takes 30 units of labor to produce 1 unit of A. Clearly, Sweden has an absolute advantage in the production of good A. It takes only 15 resources to produce it in Sweden, where it takes 30 units of resources, labor, in Korea. Question 2. Which country has an absolute advantage in the production of good B? Now we need to compare the unit labor requirements for good B across the two countries. It takes 10 units of labor to produce 1 unit of B in Sweden, and that's less than the 12 units of labor it takes to produce a unit of B in Korea. So once again, Sweden has an absolute advantage in the production of the good B. If we look at this outcome, we see that Sweden is better at producing everything, and Korea is worse at producing everything. And at this point, I really hope that my wife is not looking at this one. The question, though, is, can Sweden, that is better at everything, gain from trade with Korea? And can Korea, who's worse at everything, gain from trade with Sweden? That's what we're going to be looking at next. The key thing in terms of the pattern and the benefits from trade is comparative advantage. But before we can find comparative advantage, we have to determine what the opportunity costs are. Opportunity cost is defined as the amount of one good that has to be given up in order to produce one more unit of another good. So the opportunity cost for good A is equal to the amount of good B that must be given up to produce a unit of A. The way we calculate the opportunity cost is to take the ratio of the unit labor requirements in a particular country. So the opportunity cost of A is the unit labor requirement for A divided by unit labor requirement for B. If we're going to look at Korea, then of course we're going to be looking at the unit labor requirements for Korea, which is equal to 30 for good A and 12 for good B, giving us an opportunity cost of 2.5 B for every A produced. So that's the opportunity cost of good A in terms of good B in Korea. If we want to find the opportunity cost of good A in terms of good B in Sweden, we've quickly calculated. So we find the opportunity cost for Sweden here. Take the unit labor requirement for A divided by unit labor requirement for B in Sweden, which is 15 divided by 10 equals 1.5 B. So the opportunity cost of A is 1.5 B. You have to give up 1.5 units of good B in order to produce 1 unit of good A in Sweden. Once we know what the opportunity costs are across the two countries, we can figure out what the comparative advantage is. Comparative advantage is defined as a country has a comparative advantage in the production of a good if it can produce it at a lower opportunity cost than another country. If we look at good A first, we notice that the opportunity cost of good A in Sweden, which is 1.5 B, is less than opportunity cost of good A in Korea, which was equal to 2.5 B. This means that Sweden has a comparative advantage in good A. If you want to find the opportunity cost of good B, what we want to do, or what we have to do, is just take 1 divided by the opportunity cost of good A. So, for example, the opportunity cost of good B in Korea is equal to 1 divided by 2.5, which is equal to 0.4 A, which is less than the opportunity cost of B in Sweden. 1 divided by 1.5 equal to 0.67 A. And therefore we can conclude that Korea has a comparative advantage in good B. So Sweden, comparative advantage in good A. Korea, a comparative advantage in good B. Once we understand the pattern of comparative advantage, or who has comparative advantage in which good, we can easily determine the pattern of trade. So, since Sweden has a comparative advantage in good A, we know that Sweden's going to be exporting good A to Korea in return for good B. This is going to be the pattern of trade then. So we see what the pattern of trade should be, but it's not obvious what the price will be. You know, how many of good A will Sweden have to ship to Korea in order to get one good B in return? And how many good B will Korea have to ship to Sweden in order to get one good A in return? That price is what's called the terms of trade. It turns out that the terms of trade will have to be in between the two countries' opportunity cost. So if we're looking at a terms of trade that is expressed as how many of good B it takes to get one good A, then we have to look at the opportunity cost of A in the two countries. And we have already calculated these things. We know that the opportunity cost of A in Sweden is 1.5 B, and the opportunity cost in Korea is 2.5 B. So we know that the terms of trade is going to be in between those two numbers. Here the question is, what is the maximum and minimum price of good A in terms of good B at which trade will take place? Well, it looks like the maximum price is going to be 2.5 B, but we have to make sure we understand why that is. So Korea's opportunity cost of A in terms of good B is 2.5. So in order to produce 1 unit of good A by itself, Korea would have to give up 2.5 units of good B. It probably makes perfect sense to you that Korea would never be willing to buy good A from Sweden if they would have to pay more than 2.5 B in order to get it. Right? Because if they had to pay, say, 3 B if they buy it from Sweden, it would be a lot better to just do it themselves for only 2.5 B. So 2.5 becomes the maximum price of good A in terms of good B. The minimum price, we can think of it slightly differently. In Sweden, in order to produce 1 unit of good B, they would have to give up 2/3 units of good A. That was their opportunity cost for good B. So they would never buy good B from Korea if they had to pay more than 2/3 of an A. Right? So if it costs, for example, 1 A to get a B from Korea, Sweden would be better off if they just do it themselves. Of course, 2/3 A for a B is the same as 1.5 B for 1 A. And therefore we can easily say that the minimum price of good A in terms of good B is 1.5 B. Alright, so we have determined that the terms of trade has to be between 1.5 B per A and 2.5 B per A. Here we simply assume, because I have to pick one number, given that we don't describe preferences and the demand side. So we just assume that right now the terms of trade is 2B per A. This makes sense because it's in between 1.5 and 2.5, so it's believable. The questions we have right now is, why will both Sweden and Korea benefit from trade? The best way to look at this question is to figure out if both countries can obtain one of the goods cheaper than if they did it themselves. So here we have a comparison between indirect production versus direct production. We have already seen that if the terms of trade is 2B per A, then Korea is better off because 2B per A is less than if they did it themselves, which would be 2.5 BA. So Korea can obtain more A using fewer resources than they could before. At the same time, Sweden can get an A by giving up, or get a B by giving up 1/2 A, which is less than the 2/3 A they would have to give up if they produced the B by themselves. Again, indirect production here, that is, produce A's and trade for B, is better for Sweden. Trade is good for both countries. Next, we want to look at a diagram, and we're going to use that diagram to show that both countries can actually consume more after trade of both goods than they can before trade. The way to do this is to use the production possibilities frontier, which shows a combination of two goods that can be produced given resources and technology. And remember, resources here are the 9,000 workers, and technology is given by the unit labor requirements. Given our resources, we can draw our production possibilities frontiers for both Sweden and Korea. Given that Sweden has 9,000 workers and a unit labor requirements for A is 15 and 10 for B, we can figure out how many units of A and B Sweden could produce if the country allocates its resources only to each of those two industries. So for A, we can see that Sweden can produce 600 units of A. That is equal to 9,000 divided by 15. Sweden could also produce 900 units of B, because they can take all their 9,000 workers, put it into B production, and it requires 10 workers for every unit of B produced, and therefore Sweden can produce a total of 900 units. Since technology always stays the same, the production possibilities frontier will be a straight line. We can draw the PPF for Korea as well. Korea has 9,000 units of workers, and the unit labor requirement is 30 for Industry A and 12 for Industry B. Therefore, we can calculate that in Korea, they could produce 9,000 divided by 30 equals 300 units of A. Or Korea could produce 9,000 divided by 12 equals 750 units of B right there. Again, technology stays the same for Korea, and therefore the production possibilities frontier is a straight line. In the problem setup, we said that each country has preferences such that they want to allocate half their workers to each industry. So we know that there will be 4,500 workers in Industry B and 4,500 workers in Industry A in both countries. That means that in Sweden, so before trade, they will be producing 450 units of good B and 300 units of good A. And in Korea, they will be producing 375 units of good B and 150 units of good A. Since this was what they choose to do, it must be that Sweden's preferences and Korea's preferences are such that this allocation of labor across the two industries produces a tangency with a community indifference curve. When trade is allowed, however, Sweden will move towards specialization in the good A production. So they go from producing at this point to start producing down here, and then Sweden trades at 2B per A, the terms of trade, and that allows Sweden to reach a higher indifference curve, making Sweden better off. The same is true for Korea. They will specialize in the production of good B, then they will trade at the terms of trade, 2B per A, allowing them to reach a higher indifference curve and therefore be able to consume outside of its production possibilities frontier, making both Korea and Sweden better off after trade compared to before trade. Alright, we have now showed first by comparing indirect production to direct production, and then looking at a PPF and a community indifference curve, that Sweden and Korea are both better off from trade. So that entire countries are better off from trade. The question here, question number 13, is who will be the winners and losers from trade in Sweden and Korea? We have to remember that we are assuming perfect factor mobility, which means that workers can go to whichever industry they would like to be working in. And without doing any math, we have seen that in Sweden, workers will be moving from the B industry to the A industry, from its comparative disadvantage industry to its comparative advantage industry. And therefore, all workers will be working in the export industry, which is the industry that benefits from trade. And since everyone is working in the export industry, everyone benefits from trade. The same is true for Korea. They move from the A industry to the B industry. Everyone is working in the export industry, everyone benefits from trade. So with perfect factor mobility and only one factor, labor, we have that trade is good for the entire nation and everyone working and living within the nation. Trade is good for everyone. However, the conclusion that trade is good for everyone might not hold true if labor is perfectly immobile between industries. So that labor employed in the A industry cannot go to the B industry. That would be true for Korea. And labor in the B industry cannot go to industry A, which they would like to do in Sweden. So if we look at Sweden here to begin with, we started out our story having 4,500 workers in the B industry, where they produce 450 units of B, and we had 4,500 workers in the A industry, where they produce 300 units of A. And with perfect factor immobility, then the workers will be stuck right here. So even after trade, there will be 4,500 workers in each industry, and Sweden will be producing 450 units of B and 300 units of A. There's nothing they can change about that. Given that the workers cannot move out of their respective industry, will there be some winners and some losers in Sweden? And the answer is yes, there will be both winners and losers. In this diagram, we try to show all the outcomes before trade, after trade with perfect mobility, and after trade with perfect immobility. What we have here is that before trade in autarky, in Sweden they will produce 450 units of B and 300 units of A, and if you don't have trade, whatever you produce is what you consume. So before trade, the consumption and production point is right there. after trade, if you have perfect mobility, then Swedish workers will move out of the B industry and into the A industry, and they will specialize in producing A, and therefore they will be able to produce 600 units of A. They will then trade those 600 units of A for B according to the terms of trade. So for every A you give up, you get 2B. A to B, and that's going to be the slope of this terms of trade line. And given our preferences as shown by this community indifference curve, in Sweden they will consume or produce right down there, and they will consume right up there. You have separated the production and the consumption points, and they are much better off because they can reach a much higher community indifference curve. Now, the problem is that if you have perfectly immobile labor, then you're going to be producing always in this spot right here. However, you can still trade at the terms of trade. So you can still trade every A unit that you have for a unit of B, and that, and the ability to get more units of B, which given our preferences is what you would like to have, allows you to reach a higher indifference curve. So even though you cannot achieve production efficiency because you cannot specialize in the good in which you have a comparative advantage, you can still achieve some consumption efficiency by trading one good for the other at a better or more favorable price to you. So even when you have perfect immobility of factors, the country is better off. But, and this is what we're going to we'll be talking about later and see it later, of course the workers will not all win. In this case, the exporters will be better off, and the import competing industry is going to be worse off. More on this later. That concludes our basic Ricardian model, which is, and this is a little bit scary, our simplest model in this course. Thank you.